So we're looking at a CAPE Applied Mathematics Unit 2, 2017, Paper 1. So the first question we have here is to find the expression for S. So we have S here, which is the output of this system. So in order to figure out an expression for this, I need to figure out all these inputs coming into this point here. So let's start off with this first one. So this first one, we have P and Q coming through an AND gate. This here is an AND gate. So we have P and Q. So this is coming through here. And on this one here, we have a NOT gate. So it's R passing through this NOT gate, so coming out through this would be not R, not R. Now for this particular part, even though this is not part of your syllabus, this here is an OR gate by itself, but when we put this circle on it, it makes it a NOT. So what we're saying here is that imagine having a gate coming out like this, that is a OR gate, and right after that we have one of these, which is a NOT gate. Okay, so that's what this means. Just in case you never saw a NOR gate before, this is what a NOR gate is, which is just like what we saw in the question. This is a OR gate. So there's a difference between the two, and they both give different outputs. So if we're putting these two together, we'll end up saying that we have P and Q. This is coming in as one input. So this one input represents this. So I'll just write it as a line for this. This one is for this one in particular. And coming into this is a R. Remember we said this portion is a R. So we say the R, which is a V symbol. So P and Q coming into this R, not R. And remember we said that after we pass through the R gate, we come out to a NOT gate. So if we was to put this whole thing in brackets, remember once it comes out of this, it would be a NOT. So this particular question had an error in it. So what would have really been the case, as you can see, they had the brackets out here. What we would have really do is have outside here a NOT symbol. So the answer would have been this one right here. None of these answers here would have worked for this particular question, just because of this NOT factor that we see over here. All right, so this here was a little error on the question that we had here, but technically this would have been the answer. Now for question number 2, the truth table for P implies Q. The most important thing for this one is that if you try to remember anything for this particular question, always remember that once this first one is true and this one is false, that means the output is going to be false. This is the only time that output for this question would be false. When the first one is true and the second one is false. Once that is the case, everything else is supposed to be true. So when we're looking at these answers, you would see that it says this one has true and false. However, we have a false out here. So we know this can't work. So this one here, we have a true, then a false. False and true gives us true. False and false give us true. Whatever the case is, we know that it's true and false. So this here is our answer. Everything else is expected to be true. This one, they give us two different false situations, so that couldn't work. And likewise here, this one had 3 falses, so this couldn't work. So obviously, best answer would have been this. How I like to think of it is, if you're using ones and zeros, if the first number is a 1 and the second one is a 0, once we're using implies, which is this arrow here. Once you see anything that reads like 10, for the first input is 1 and the second one is 0, you know that's the only time that it's expected to be false. Everything else is true. So you can use 10 as a little secret to remember how to do this. Alright, so we keep it rolling with this question here now. So we have a activity network here, and we're trying to figure out what is the earliest start time. So the earliest start time, we'll write the earliest start time to the top. Usually once we finish, we'll come back and do the latest start time, which would be the one at the bottom. But we're only required to do the earliest start time. So looking at A, my concern is, are there any other situations coming into A? Remember, our objective is to get to D. This is the section that we want to get to. So starting with A, remember the earliest time A could start is at 5. So it takes 5 days before we can actually start A. And for B, there are 5 days as well before we could start B. 5 days before we could start A, 5 days before we could start B. Now this is a critical part. Whenever we're moving right, we always look for the highest number, okay, when we add them together. So for instance, since we're looking for the highest number moving to the right, if I'm coming to D, what is coming to D? We have 2 situations coming in. We have 6 here coming to this one, so it's going to be 5 plus 6, which would give us 11. So 11 is one of our options if we pass from A to D. Now, to get from B to D, it would be 5 plus 4, which is 9. Now, when you look at both of them, what is the highest number? It's 11. So 11 is the earliest I could start B. What does this mean? Although it takes 5 days to start both tasks, remember, B takes 4 days to complete and A takes 6 days to complete. So think of it like this. Think of A as one of your friends and B as one of your friends. You want to go somewhere, your friend A and your friend B takes 5 minutes to get ready. Now, to walk to your house, you're D. To walk to your house, A takes 6 minutes to walk to your house and B takes 4 minutes to walk to your house. Now, if B is walking to your house, altogether from getting ready to walk into your house, B would take 9 minutes. And A now has to get ready in 5 minutes and then walk to your house in 6 minutes, which would take 11. So A is like the late friend. Everybody always leaves late because of this person. So you have to wait until the last person reaches before you can actually leave to go to the shop. So therefore, in this case, that's why we look at the highest number. So the highest number in this case would be 11. So our answer is 11. In case any of you was wondering, this arrow here is an error. This was actually supposed to be pointing into the other direction. So you would have seen this supposed to point like this. So here is another question in this past paper so far where we found an error. This was supposed to be pointing this way. Otherwise, we would have to go from A to C, then C to F, and F back to D. And all of these numbers would have been, say for instance, 5 plus 6 is 11, plus 3 is 14, plus 2 is 16. And clearly the answer is not there. So this again here was another error in this paper. So this should have been pointing this way instead of the way that they had it. Number 4 asks for the degree of the vortex F. So this is F, and when we're talking about vortex, we're talking about how many lines do we see coming into F. So we have here 1, 2, 3. The degree of the vortex of F is 3. Now, for this particular question here, it says that we need to identify which of the following sets of inequalities would represent the shaded portion of the graph. So this is the shaded portion of the graph that we have here. Now, they gave us two lines, x plus y 20, 3x plus 5y 75. Since it's only two lines, I just need to figure out what one is, and then obviously the next one is that line. This one that goes from 20 to 20, I know that this one is the one that says x plus y is equal to 20. Note how I have equal, that's just because I'm naming the line. That has nothing to do with the feasible region, meaning the area where it's shaded. How do I know that it's x plus y equal to 20? So when x is equal to 0, if I was to substitute this, it would say that 0 plus y is equal to 20. Therefore, I know that y is equal to 20 when x is equal to 0. So we have a little coordinate there that we could use to plot it, which would have been 0, 20. Likewise, when I do it for when y is equal to 0, so when y is equal to 0, and I put this into here, I'll have x plus 0 is equal to 20. Therefore, x would be equal to 20 when y is 0. So I could write this as a coordinate, x being the first value for x, so 20, and then 0. So then we know that the coordinate for this one here is 20, 0, and 0, 20, and then we connect that. So that's how I know that this red line is x plus y. So that means that the other line is obviously this one here. Now I need to identify where is a shaded region shaded relative to these two lines. Since my y is positive here, I'm looking at it from the perspective that once we're looking at a y graph, we're looking at shaded up and shaded down. If it's saying that y is more than, it would be shaded above the graph. If it says y is less than or equal to it, it would be saying that it's shading below. Say for instance with this graph, you see how it says y is less than x plus 2? I do not care about the x plus 2 and that stuff. All I care about is the y part. And notice how it says y is less than or equal to. That's because this line is solid. If it was just less than, it would have been dotted. But the point is, it says y is less than, so I'm shading underneath the graph. Because if you think of the y values, as you go down to the lesser numbers. Okay, so y is less than means that any line you would shade underneath it. If it says y is more than, that means you would shade above the line. So for instance, you see here we have y being more than, so we're shading above this. And you see how we have the dotted line because the equal sign is missing. So yeah, we shade above when it says y is more than, but y has to be positive. So back to this here now. So in this particular instance, it's being shaded above. So that means whatever inequality we have, it must say that x plus y, I'm not concerned about this x plus part, my focus is what is being done for the y. So let me focus on the y. We're saying in this case that y is above. That means it must be more than, and because the line was solid, it would be more than or equal to 20. So I'm just looking for answers that has x plus y is more than or equal to 20. So only this one so far, this one as well. This one can be the answer because it says less than. This also says y is less than or equal to, so we can't use that. It could only be one or two of these answers here. Now let's look at the next one here now. So for this case now, as you can see, the shaded region is under the green line. So we are saying that if I'm writing this again, I'm looking at 3x plus 5. As I said, I don't care about those numbers next to this. I just care about the y. And with the y, because it's shaded under, and we have a solid line, you see how it's shaded under the green region, under the green line? That means it's less than. And the solid line shows equal to, and we could put here 75. So then my answer should have y is less than or equal to 75, right? So when you look at this, this has more than, so it can't be this. So only option is this one right here. So our answer is this. All right, so we have question 6 here. It says a compound proposition is given by if Richard revises daily, he will get a grade 1 in applied maths. Let's call that P. Let's call this Q. Implies Q. So P has to happen and then P, and then we implying that Q takes place. Now when it comes to contrapositive, the contrapositive would mean that we not only swap these two, but we change the sign. So then I would have Q swapped, but I'll change whatever this is saying, implies P, which is swapped, and the sign is also changed. So because it's, P right now, if I change the sign, it would be not P. So what we're saying is that if we want to find a contrapositive of this statement, we have to say it in a way that says not Q implies not P. So what this is saying now is if Richard does not get a grade 1, so now we have to include for that not get a grade 1, okay? If Richard does not get a grade 1, then Richard did not revise daily. So the closest one that would give us to that would be if Richard does not get a grade 1 in applied mathematics, then he did not revise daily. So this one here is the closest to what we just described. Alright, so this question says, if activity P has activity Q as an immediate predecessor, then this may be represented as... So what we're saying is, Q is an immediate predecessor, okay? So that must mean that Q had this job before it was given to P, alright? So Q had this job before it was given to P. So pre meaning that it comes before. So Q has to come before. Think of it like preschool. Before school to some degree. Before you go to primary school, we call it preschool. So Q is the immediate predecessor of P. If activity P has an activity Q as an immediate predecessor, that must mean that Q had the job before P. So the only thing that gives us that would be number 2. Now 3 also has Q as a predecessor, however it's not an immediate. That's a key word here, immediate. That means that Q had to have a job immediately before P. Okay, so the only one that works here is 2. So our answer in this case is B. So because this here has something in between is why we can't use this. It's not immediate. This is more English understanding as opposed to anything else. Okay, so for this particular question it says in Boolean algebra for a true value A and 1 is equal to, so let's say we had a truth table. So we have A, the inputs that we could have for A would be 0 and 1. And what we're saying here is for 1, the other input that we can have, we know that anything for 1 could always be 1 and 1 because it's 1. Okay, so remember, for A and 1 to work, the only time this could work is when we have both 1s. So this here is 0 and 1, so the output would be 0. 1 and 1, so the output would be 1. So if you look at this carefully, notice how it matches with A, alright? So what's going to happen with this case here is A and 1 will give you A. So that's a little quick way how you can work this out. For this particular question now, we are looking for the minimum completion time in days of this table. So this is funny because this is actually a paper 1 question, almost asking you a paper 2 question. But in essence, what we have to do is complete the table for this, right? So we're going to use a little algorithm to help us. So we could label it out. So we're going to have P, P, Q, R, S, T, P, Q, R, S, T. So this is the first one. So P does not depend on no one. Q same thing. R depends on S and P. S depends on P. T depends on S as well as P. So the only ones that you see that's not pointing to anything here is P and Q, okay? So when we start, the first two people that we'll be going to would be P as well as Q. Alright, so let's try this again. So the second one that we'll have is, since we left out P and Q the last time, now we'll only have R, S, and T. So with R, S, and T, who does R depend on? S and P. So we know R is going to S. Who does S depend on? P. There's no P to point to. T depends on S and P. So in this case, we will only have S left. So on this next wave, we would have S. So it says that S depends on P, so we could point this to S. Now the next one we need to do, we have left only R and T. So R and T. So the third one, R goes to who? S and P, there's no S and P there. T goes to who? S and P, there's none there as well. So therefore, when we put the R here and we put the T here, we know that these here would be the third leg, and this would go to the end. We have the end here. So who does R depend on? S and P. So S has to go to this, and P also has to go to this. And T, likewise, depends on S and P, goes to this one as well as this. So now Q, no one depends on Q, so Q goes straight to the end. T goes to the end as well, and R goes to the end. So now we could put on now we could put on each at a time. So P takes how long? 10 days. So we could put 10 here, 10, 10. For S, for Q, we take 6 days. For R, we take how many days? 7. For S, we take 14. And for T, we take 4 days. Now we need to figure out what would be the minimum completion time in days coming to the end here. So let's start this off. So whenever we're moving from left to right, remember we said we look for the highest number as expressed earlier. So we start off here, we have P, we go to 10. So P obviously starts on 0. Let's use a different color. So P starts on 0. Q also starts on 0. So now coming into S, what is coming into S? So coming into S, we only have one thing coming into S. So that means the earliest S can start is 10. S can start at 10 days. Now we need to see who else we can look at. So R, we have two things coming into R. So with R now we have either the 10 coming in. So for R we have the 10 coming in. That's the first one. And then the second option is this 10 here, because S takes 10 days to complete, plus the 14, which would be 24. So 10 from here, it takes 10 for S to start. And after that 10, it takes 14 to complete. So then we'll have 24 by the time we come out of R. That's the highest number. So for R, we take the 24. Now looking at T, we have the same concept. We have S starting at 10, and we have a 10 coming here as well. So for S, we have a 10. But in this case, because we're coming into S as 10, and we add in this 14 to get to T, because it takes 14 days for S to complete, that means we have 24 as well. So right here, our answer for the earliest start time for T is 24. Now, coming to the end, these are the options we have. The first option we have here is 6, so we know clearly that's not the answer. Now 24 plus 4 to get to the end. So that's 28. That's if we was to use this path going to T. However, R to the end would be 24 plus the 7. So 24 plus 7 is 31. Remember what we said, we use the highest number to get the value moving to figure out what's the earliest completion time. So in this case, we would end up using 31 because for the end, the highest number is 31. So our answer is 31. So as you can see from here, we should select 31. It's kind of ironic that the highest number here is 31. So this question looks like a theoretical question. It says, which of the following statements are not true of the Hungarian algorithm? So it says the underlying assumption is that if there are n jobs, then there are n machines. This is true because whenever you're doing a Hungarian method, it must have the same number of columns and rows. So it has to be like a 4x4, 5x5, and so forth. So this is true. So anything with 1 can't work, this can't work, this can't work, this can't work. Wow, that's actually funny that the only option left is C. But let's just go through it just to make sure. So adding a constant to a row or column does not change the solution. So if you add a constant only to the row, it will impact the overall answer. This here is false. It can only be used to identify minimum assignments. Remember, we could also use Hungarian to find maximum assignments. So this here is also false. So 2 and 3 are false, therefore our answer is this. Before I start reading, I want to see what this is going to ask me to do. It wants me to figure out the variables in this problem. What are the variables? All I care about is the variables. So a baker makes batches of large cakes and small cakes. A batch of small cakes takes 1 hour to bake and 2 hours to decorate. So we're talking about small cakes here. Then we have a batch of large cakes takes 2 hours to bake and 1 hour to decorate. So we're talking about large cakes here. So a batch of large cakes, and earlier we said a batch of small cakes. So technically you can kind of see already that these two here mentioned are already the variables without even continuing what we are doing. So if you look at this now, let's say the baker can bake for 8 hours and decorate for 7 hours. He makes a profit of $12 on a batch of large cake and 20 on a batch of small cake. So what's going on here is talking about constraints and stuff. That's not what we're interested in right now. We're interested in the variables. So the variables here would be the number of batches of large cakes and the number of batches of small cakes. Now this here is the answer. Okay, so for this question, it says the region that is satisfied by the constraints. Let's figure out what these are. So I'll use them in color code. So x is more than or equal to x. The line that represents this, we're talking about this line here. So when x is 0, that's what we're looking at. X is 0 at the y-axis. And then for this one here, y is 0 at the x-axis. Numbers where x is more than for this green line would be shaded this way. So it's everything either on the right, and then for the blue one it says y is more than. That would be everything above, because we remember we said earlier when y is more than we shade above. So we know for sure that for two of those it has to be any one of these. It works for any one of these two here. Now these two are the ones that we need to figure out. Now based on what we did last time, from the earlier question, if I substitute, I could figure out which one is which, right? But based on the fact that this one is a 6 and it just has 1x plus 1y, I know that this line here represents the line x plus y. Now the thing with this one, it says x plus y is more than 6. So remember what we said earlier, when it says y is more than, we are looking above the line. So for this case, that already eliminates r and q, because r and q are below the line. So r and q cannot be part of our answers. Okay, so we know these are out. So it's either s or p. So let's look at the next one now. So with this particular one here, it would be this line here. Now again, all I care about is looking at the y part. This is all I want to look at. Y is less than. So this is telling me y is less than 8 in my brain. I'm not even considering this part here, even though it's important. That's just to help me with the line. So when it says y is less than, that means we're shading underneath. So if I'm shading underneath, that means that the p is not going to be there. So you know we could cross this out as well too. So underneath this line here, we would end up in this region here. So our answer is S. So S represents the region that satisfies these constraints here. So it says a project manager can use critical path analysis. Critical path analysis. So this is similar to what we were doing here over here, but we didn't do the critical path part. So the critical path analysis to sequence activities on a project. So when we sequence activities, that means we put them in order of which comes first, which comes after, and so forth. And based on what we did earlier, you all would realize that we did that. So one definitely is an option. Now the second one, give an exact cost for a project. Now, we wouldn't get an exact cost of a project from my activity network. Remember, this one mostly deals with time and sequencing activities. So we know for sure that 2 cannot be an option. This is out and this is out. So we only left with one more thing. So identify critical activities. Now this critical activities would be the critical path. And that's the whole point of a critical path analysis, to find the critical path. And in order to find a critical path, you need to know the critical activities. Therefore, this is the answer. Our answer here is right here. So we have a 2-part question here linked to the same table, our last question in module 1. So it says the objective function in the linear program model is to maximize which one of these? So without even checking through this, usually whenever we're talking about maximizing and so forth, they tend to be like profit or, anything that deals with optimizing numbers and so forth. So in this case, I know that the objective function in this case works with the profit. So in this case, we just need to match 18 with whatever A is. So it's like saying 18A and then 21 of model B. Now if you look here, they said let X and Y represent the number of model A and model B. So X is this and B is Y. You can get $18 profit from X. So if you had like 3 items of X, you just multiply that by 18. That will give you a profit. And then likewise for part B, just do 21 times Y, and that will give you your maximum profit. So 18X plus 21Y will give us our maximum profit. The best one that matches this would be over here, 18X plus 21Y. This one asks for the constraint. A constraint in this linear program model is, so while we're at it, we might as well work out the constraints. So it says each week there is a total of 400 man hours. So man hours, you see here, we only have 400. Okay, remember we say this is X, this is Y. So then for this one, we have 400. So that means we have a limit. So we can't go above 400. So I can say one of the constraints would be 4X plus 18Y is less than or equal to 400. This one is relation to hours. Now, why did I say less than or equal to? You can't have more than 400 hours is what they're saying here. It has a total available of 400, so that means we have a maximum number of hours we can use. If you look at this here, I could simplify this because all of these are multiples of 2, so I could divide each of these by 2 to reduce this. So then I'll end up with 2X plus 9Y is less than or equal to 200. Now if I'm looking at this question, it's actually giving me 2X plus 9Y, but it has more than or equal to. So I can't use that. Remember we said here that the values for this, they have to be less than the number of hours because that's our limited resource here. So let's try the next one now. So the next one says the cost of production. So a total of 900 available for production costs would be this 900. So now thinking of this 900, I'm saying that if I'm only allowed $900, I can't go above 900. So therefore, I would have to say 15X plus 12Y has to be less than or equal to 900. Now, if you look at this, 15, 12, and 900, they are multiples of 3. So we divide all by 3, and we'll have 15 divided by 3 is 5X plus 4Y, which is less than or equal to 300. Remember, 900 was the limited that max I could have, so I could only have less than or equal to 900, which is why I used less than or equal to in this case. So based on this answer now, I try to look for it here, and as you can see here, this here first of all was wrong because of the bad sign they use. Now the only answer we got here that makes sense would be this here. Okay, so this here is our answer. Alright, so that's it for module 1. Let's look at the module 2 question. Alright, so for this particular question in module 2, we are saying that for any value of X, the probability is equal to a quarter. So that means that this one here is equal to a quarter. The probability of getting 20 is also equal to a quarter. The probability of 30 is also equal to a quarter, and finally the probability of 40 is equal to a quarter. So what this is saying in essence is that they want us to figure out what's the probability of someone getting a number that's more than or equal to 20. So the values that would be equal to more than or equal to 20 would be from here upwards. So as you can see here, we have a quarter plus a quarter plus a quarter, which would give us 3 quarters. Therefore, our answer is C, 3/4. Now they say there are 12 applicants for a job. The number of ways of selecting 4. When we're talking about selection, the topic we are looking at is combinations. If we were saying arrangements, we would have been looking at permutations. Now this question is saying the number of ways of selecting. So we have 12 overall people, and we are selecting 4 of them. So we would have to put 12C4 into the calculator. Once you put 12C4 in the calculator, you should get 495. So our answer in this case is 495. So this question now says the number of telephone calls to a hospital switchboard in a given 10-minute intervals may be modeled by a Poisson distribution. So they actually told us that it's a Poisson, which is great, which has a mean of 3 calls per 10 minutes. So we have 3 calls every 10 minutes. So the average is 3. Now they're asking us for the probability that at least 1 call is received by the hospital. So we're looking for the probability of a value X being more than or equal to 1. So it has to be more than or equal to 1. Now, the fact that this is Poisson, this is average, and we do not have a cap. Literally, if I try to answer this question, I'll be here all day because you'll have to go work it out for 1, for 2, for 3, and so forth up to infinity. So there's no point in doing that. So how I like to think of it, I like to think of it of what numbers are not included in here. If I say more than or equal to 1, I'm talking about 1, 2, 3, 4, 5, 6. Now, I did not call the probability of 0. It should be x is equal to 0. So if I could work out what this value is, all I have to do is subtract it from 1. So 1 take away whatever this probability is, and this would be equal to this over here. So the Poisson distribution, the formula goes like this: e to the power of minus lambda, which is 3, times lambda to the power of whatever the value we're looking for is, which is r, over r factorial. So in this case, we're saying e to the minus 3. So e to the power of minus 3 times 3 to the power of r, in this case r is 0, divided by 0 factorial. Now, e to the power of minus 3 is e to the power minus 3. 3 to the power 0 is 1, so it's like saying e to the minus 3 times 1. And then we'll have 0 factorial, which is 1. So if I was to simplify this, I'm basically saying that this value here is equal to e to the power of minus 3. Therefore, my final answer to work out what this is basically be 1 take away e to the power of minus 3, which is this answer here. So our next question is a theoretical question. It says the observed frequencies of a goodness of fit test are the frequencies obtained from the performance of an experiment. This is the answer right here. So the observed frequencies would be the frequencies obtained from the performance. So for this one, this is Poisson again, and it says the Poisson, we want to get the standard deviation. Now in Poisson, the mean is the same value that lambda is. So this right here, this 4 represents lambda. We usually write Poisson in this form. So mean is equal to lambda, and lambda in this case is equal to 4. So the mean is equal to 4. Now, as it relates to the variance is also equal to lambda. And we know that a standard deviation is the square root of the variance. So therefore, if lambda is the variance and standard deviation is the square root of the variance, and lambda is 4, that must mean that the standard deviation is the square root of 4. Square root of 4 is 2, so the standard deviation of this here is 2. Now for geometric, we have a similar situation with a different formula. So geo is given by p, so p represents the probability. Now the mean for the geo is written as 1 over p, and the variance, this is a tricky one to remember, is usually written as q over p squared. Whatever q is, we put that over p squared and we will get our answer. So in this case, how do we get q? We know that p already is 0.25 and q is equal to 1 take away that. So 1 take away 0.25 gives us a value of q. That's just standard. So then the value is 0.75. So if I was to put this in a formula, I'll basically be saying this is equal to q, which is 0.75, over p squared, which is 0.25 squared. So 0.25 squared. Now, if you put this in a calculator, you'll end up with 12. So our answer here is 12. 3 teachers are to be selected from 5 men. So you want to select 3 teachers from 5 men and 4 women to attend an overseas conference on math. The number of ways in which 3 teachers can be selected so as to contain less than 2 women. So we want to select 3 teachers and we have to select from 5 men and 4 women. But there's a condition. We must have less than 2 women selected. So when it's saying less than 2 women, that means we could have 1 woman or no woman. Pay close attention to that. It says less than 2. So if I told you, give me less than $2, you're not going to give me $2. You're going to give me anything that's less than $2. So our first condition could be 1 woman. So if we have 1 woman, we must have what? We need 2 more teachers. So we could have 3 teachers. So we have 1 woman and 2 men. How many women do we have to choose from? We have 4 women to choose from. So I could say 4C1 times, I have 5 men to choose from, so 5C2. That's my first situation. The second situation now is we could have 0 women, and if we have 0 women, we must have 3 men because we need to have 3 teachers. So here again, I'm choosing from 4 women, no woman, so 4 0, and then we have 5, select or choose 3. So what I need to do now is work out these 2 values and then add them together. So you have to use this in your calculator. So for this first one, we'll get 40, and for this last one, we'll get 10. So both scenarios, when we add them together, we'll get 50. Therefore, our answer is Okay, so right now we have a test here now that says it is thought that a height of centimeters of 100 cadets is normally distributed with a mean and standard deviation of 1/8 and 2 centimeters respectively. A chi-square test is performed at the 1% level to verify this, and following table is obtained. So the first thing they want us to determine would be the number of degrees of freedom. So as you can see here, we have 4 options. So this is our first option, second, third, fourth. So we have 4 options, and the degrees of freedom would be equal to n take away 1. So in this case, it's going to be 4 take away 1, which is 3. So our answer here is 3. Now the next question wants us to look for the critical value of this test to 4 significant figures, So if you're looking for the critical value, what we need to have is the degrees of freedom, which we already got, and we also need to use the levels of significance. So we have a 1% level of significance. So I'm using the chi-square test values. So 1% can also be written as 0.01. If I do 1 divided by 100, it will be 0.01. So therefore, my answer to this question would be 11.34. 11.34 is my answer for this particular question here. Alright, so this question says if the number of goals per match is represented by x, where x is a Poisson distribution. So this next question says if the number of goals per match is represented by x, where x is a Poisson distribution and has an average of 1.6, the value of a to 2 decimal places is, so this is what we're looking for. The value of a here to 2 decimal places, what would that be? So if we're looking for the value of a, we're saying that the value that we're looking for the probability as would be for 2. Okay, so they already did it for 0, 1, and anything that's more than or equal to 3. So we have to determine it when the probability is equal to 2. Now back to the equation that we used the last time. We said e to the minus lambda times lambda to the power of r. So in this case, this would represent our r over r factorial. Now just to know, this r and this x is like, this is a general formula, but we also use it with x as well too. So even if I was to say that this was to the power of x, it's the same thing as this here. Okay, so what we're saying is e to the minus lambda. So we said that the average is 1.6. We would say 1.6 times 1.6 to the power of 2, and that would be divided by 2 factorial. So if I put that in my calculator, 0.2584. So now I have this value of 0.2584. What I need to figure out now, the total number of matches that are possible to play. So let's show you 2 ways of doing this. So we have 11 plus 13 plus 15 plus 11, which gives us 50. All I need to do is multiply 50 to 0.2584, and that will give me my overall number. So this gives me 12.92. Now, an easy way of working this out as well too was all of these values here have to add up to 50. These 4 digits here have to add up to 50. So what we need to do is add up these numbers, which would give us 37.08. Now, if we say 50 take away that, we would be left with our answer, which is 12.92. So that's another way of calculating this as well too, which is much easier to do. Question 26. It says using the letters O, S, T, M, N, A, U, the number of arrangements where all the vowels are together. So we need to figure out how many vowels we have. So vowels are A, E, I, O, U. So we have 1, 2, 3. So we have 3 vowels. So what I like to do is think of it as grouping them together. So we have O, A, U together. And then we're now left with S, T, M, and N. So we have all the letters 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Now, if we want to have all the vowels together, we have to group these together and kind of think of them as just one. Okay, we're thinking of them as just one option. Okay, and then we have here a second option, third option, fourth option, and a fifth option. So it's like we're thinking of it like, oh, we have 5 different unique items and we're trying to arrange these 5. So for that particular first part, it would be 5 factorial because we're arranging these 5 items and keeping this together. Now within this arrangement here, remember we have 3 items. So there are different ways of arranging this, which would be 3 factorial. So there's a different number of ways of arranging this, 3 factorial ways. So therefore we have to multiply the number of ways we can arrange these letters themselves to the way we can arrange these individual sets that we have here. Answer would be 5 factorial times 3 factorial. So next one says a biology student finds that on average 10 milliliters of pond contains 4 ammorbate. Now from time they say on average, I already know this has to be a Poisson, okay, because it's talking about an average in a particular time or space, and in this particular one is the space. So the space here being 10 milliliters of a pond. They say if 10 milliliters of pond water is sampled, the probability to 3 significant figures that they are exactly 3 ammorbate. So we are saying, let's just say we have X for Poisson, the average is 4. We want to find the probability of when it's equal to exactly 3. So we go back to that formula that we've been using today. We have this times to the power of, this time let's use it as X or R, whichever one you want to use, over X factorial. So in this case, we would say e to the power of lambda, which is this 4 here. So it's e to the power of minus 4 times 4 to the power of 3 divided by 3 factorial. So when you look at this now, we would get in the calculator 0.1953 so forth, but they said to 3 significant figures, so we counted first non-zero digits, so we have 1, 2, 3, therefore it's 195, 0.195. On a shelf there are 8 books, 3 of which are mathematics books. The remaining 5 are chemistry books. What is the probability that all mathematics books will not be together? So in order for me to do that, what I need to do, I'll try to group it just like we grouped the other ones, having the books together, and then I'll subtract that from the total number of ways of having the books all together. But if I subtract having the books together from the overall number, I'll actually get the books being not together. All books minus maths together would be equal to maths not together. So let's put that into perspective. Let's figure out how many maths books we have. We have 8 books on a shelf, 3 of which are maths, 5 are chemistry. So think of it as having 3 maths books together. We have M1, M2, M3 representing 3 different maths books, and then after we have chemistry 1, chemistry 2, chemistry 3, chemistry 4, chemistry 5. So yet again, I'm thinking of these as 5 different individuals, and this one as a 6th one. Just for reference, let's call this a 6 and all of this a 5. So 1, 2, 3, 4, 5, 6. So the first thing we'll have is 6 factorial. But remember, just like our previous question, there are 3 factorial ways of arranging these m's here. So that would be 3 factorial for this. So we say 6 factorial times 3 factorial. All right. So this here is maths together. Now all together, now all the books in total number of arrangements would be total arrangements. Since we have 8 books and we are assuming that these are distinct books, it would be 8 books, so 8 factorial. So the final answer for this, if we put this in a calculator, 4,320. If we put this one in the calculator, you're gonna get 40320. So let's go back to the maths books not together. Remember we said if we do all the total arrangements, subtract when the maths books are together, we'll get the maths books not together. So maths not together would be 40320, take away 4320. That would give us 36000. Now, this is asking us for the probability. So we have the maths books not together, which is this. All we have to do now to find the probability is put this over the total number of books. So then we would have 36000 over 40320. And once you put that in the calculator, it's gonna give you 50 over 56. My calculator actually says 25 over 28, but if you simplify this, you'll end up with 50 over 56. So the answer is C. So this question is a probability density function. This one is actually fx is equal to, we have k x to the power of 3. So what this is saying, that k is a constant, but we need to find a probability from 1 to 2. Now, if we have to integrate this, then the area between 0 to 2 should equal to 1, since this is a probability density function. Therefore, if I'm integrating k x to the power of 3, if I walk up from 2 to 0 and integrate this, I could figure out what the value of k is. Now I need to figure out what the value of k is in order to work this question out. So let's do this now. So we're integrating this. Once we integrate this, it will be k x to the power of 3 plus 1 divided by 3 plus 1. And now we need to figure out these values values for 2 to 0, the area under that, which is equal to 1. So if I simplify this, I'll end up with k x to the power of 4 over 4, and we need to figure it out for when it's at 2, 0 for 1. Now later on we're going to use the same formula. Once we figure out what k is, we're going to use the same part to help us figure out what this is. So let's go from here. So if I substitute x with 2, I'll end up with k times 2 to the power of 4 over 4, and then I'll subtract that from k times 0 for this one here to the power of 4 divided by 4, and the area of that is equal to 1. Now if I simplify this, I'll get 2 to the power of 4, which is 16. So therefore I'll say that k times 16 over 4, and this will be take away 0. So since this is 0, there's no point in putting it back, which is equal to 1. Now I can simplify this and say 16 divided by 4 is 4. So then I'll basically be left with 4k is equal to 1. Now I could divide both sides by 4. Now I'll be left with k is equal to 1 over 4. So I know what the value of k is now. The value of k is 1 over 4. So now I could use it for this same thing here. Now I could replace this k with 1 over 4. And I could say 1 over 4 times, let's say, x to the power of 4 divided by 4, right? So I'm just replacing this k here with this quarter times x to the power of 4 over 4. Okay, I know it looks a bit confusing, but just follow me here. I could actually simplify this here to make it easier to understand. So we're going from 2 to 1 in this case because we want to find the probability between 2 to 1. So if I simplify this, a quarter divided by 4 is literally 1 over 16. So then we end up with x to the power of 4, which is basically 1 times x to the power of 4 over 16. And then we're checking for the values for 2 to 1. So basically, if I substitute this, I would say 2 to the power of 4 divided by 16 minus 1 to the power of 4 divided by 16. If I work this out, this would leave me 2 to the power of 4, which is 16. So that's basically 16 over 16 minus 1 to the power of 4 is 1. So 1 over 16. If I subtract that, I'll be left with 15 over 16. Therefore, my answer for this question is 15 over 16. Alright, so this is module 3 question now. This is our first module 3 question. It's telling us in a shot put event, the probability density function for the distance thrown is given by this. What is the mean distance thrown in meters? So with probability density function, what this is asking us to do is find the expectance. This is equal to the integral of fx multiplied by x. And in this case, since the values are from 10 to 0, we will have 10 on top here and 0 here. So what we need to do is multiply x to this here, and then once we finish multiplying x to this here, we can then integrate it. Now, looking at this first part of the question, we have a number. So since this number is basically like a coefficient, I'll put this outside and we'll deal with that later on. We don't want to put it in our equation so we could have unnecessary problems. So we have 12 over 10,000. And what we're trying to integrate here is what's left of that function, which is x squared multiplied by 10 minus x. And remember, we have to multiply this again to x. Okay, so this x here, I'll just change the color. Remember, part of figuring this out is multiplying it by x. Okay, so we have to multiply it by x. So let's multiply these out here first. So x squared times 10, then x squared times minus x will give us 10x squared. So then we have x squared times x will give us x to the power of 3. And then, remember, we have to still multiply that by x. Once we do that, we can integrate. So we'll have here 12 over 10,000. So we have 10 here, 0 here. So x times 10x squared will give us 10x to the power of 3. And we subtract that from x to the power of 3 times 4, which is x to the power of 4. Now we can integrate this. Okay, so when we integrate this now, we'll end up with 10x to the power of 3 plus 1, and then we're dividing that by whatever we just did. So 3 plus 1 is what we're dividing this by, minus x to the power of 4 plus 1 over 4 plus 1. Now we can't forget to have the 12 over 10,000 outside. So now if I simplify this, I'll have 12 over 10,000, and then I'll have 10 multiplied by x to the power of 4 over 4, and then I'll subtract that from x to the power of 5 over 4 plus 1, 5. So now I have to substitute with a 0 into this formula, and then subtract it when I substitute the 0. Okay, and when I'm done with all of that, multiply it by 12 over 10,000. So we'll have here x to the power of 4 is, we replace x with 4, so that would be 10 to the power of 4 over 4 minus, we go 10 to the power of 5 because we substituted x with 10 over 5. We subtract it from 10 times 0 to the power of 4 over 4 minus 0 to the power of 5 over 5. As I told you, this is a very lengthy question. So we end up with 12 over 10,000. So we could put this in the calculator one time. So 10 to the power of 4 times 10 divided by 4. Just do that one time to, make things move on a little quicker. So then once you do that, for this particular expression here, you will get 25,000. And when you subtract that from 10 to the power of 5, you subtract it from 20,000. And in this case over here, this will just give you 0. Take away 0, which is clearly 0, over 10,000. And when we simplify this, we'll get 25,000 take away 20,000, which is 5,000 take away 0, which is just this. Alright, so now I could walk this out. So I know 5,000 could go into itself once. 5,000 to the 10 goes twice. So we will be left back with 12 divided by 2, which is 6. So our answer for this question here is 6. This is our answer right here, 6. Alright, so for the next question, it's saying that the forces 10I plus 12J and 5I plus 20J act at a point. So they're acting at one point. What would be the resultant force? So basically, we just add the i's together. So then we have 10I plus 5I, and then after we'd have the j's added together. So we have 12J plus 20J. So 10I plus 5I would be 15I. This would be 32J. Both numbers would be positive, so we'd have 15I plus 32J. So our answer is right here. The acceleration of the particle is given by, so we want to find some expressions for acceleration. So the first thing we need to talk about as it relates to acceleration, what are the units of acceleration? Once we could work this out, the acceleration is meters per second squared. Once we could get any of these to be in that form, we would be able to know what the answer is. So now this here is saying, let's have v, whatever velocity is, and integrate it with respect to time. Now, when we integrate velocity, it gives us displacement. Okay, when we integrate velocity, it gives us displacement. So this could not work. Only way this could have worked is if we was differentiating velocity. So say for instance, if this was dv over dt, meaning the rate of change of velocity per time, then we could have used this example. We know that velocity is meters per second, and if we had to divide that by time, this would have worked out to meters per second. We change the divide to times. If s was over 1, we flip that and it would be 1 over s. So then that would work out to be meters per second squared. That is if it was this, but it's integrated, which means that we are not going to get that. So we know for sure this one does not work. So the next one we have here is velocity multiplied by the rate of change with velocity divided by the rate of change in displacement. Remember, S stands for displacement. If we use our units for each of these, we should be able to work it out. So we could already cross off this because we know it's not this for sure. I also know that it's not this for sure. And just from a process of elimination, you see both of these answers have 2. So we know that 2 is more than likely an answer. But let's work that out to see. So V stands for velocity, which is what? Meters per second. We also have dv over ds. So dv over ds is the same as saying meters per second divided by, what does displacement mean? Meters. So we divide that by meters. So let's see what this would give us. If we simplify this, just like we was doing earlier, we would say m over 1. So then we would be left with m over s times, flip this, 1 over m. Now these two cancel out, so we are left with 1 over s. Therefore, dv over ds is 1 over s. And if we multiply that to velocity, which is m over s, we'll have our expression for this. So multiplying these two, we'll end up with m over s times 1 over s. And what would that leave us with? M times 1 is m, s times s is s squared, which matches with acceleration. So we know that acceleration is indeed v times dv over ds. Alright, so the next one now, d2s dt squared. So what this means is, if we had displacement and we differentiate it twice, that's what we're going to get. Displacement time graph would basically give us velocity. All right, if we differentiate that, we would get velocity. If we differentiate that again, we would get acceleration. Okay, so if we differentiate displacement, we get velocity, because a displacement time graph, the gradient is velocity. And remember, differentiation helps us to find a gradient of a particular equation, right? So if we are differentiating displacement, we get velocity, and we differentiate as velocity the second time, we get acceleration. We know that this here also is acceleration. Therefore, our answer is this. So this tells us a box of mass 800 kilograms is lifted vertically with a constant speed by a crane, taking gravity g, then the power applied to the box in increasing the height by 30 meters in 50 seconds is, so we know that power is equal to work done divided by time. Now we also know that work done is equal to force times distance. So for this case, our distance is 30 meters, our time here is 50 seconds. So we need to figure out what the force is. Now, because we're going vertically, that means our force is going up and down. And what is influenced by vertical movement? The body is influenced by acceleration due to gravity, which is 10. What is force equal to? Force is equal to mass times acceleration. So if the acceleration due to gravity is 10 and the mass is 800, we could say that the force is 800 times 10, 8,000 newtons. So we could substitute this here for 8,000. So 8,000 newtons. So the work done is equal to 8,000 times 240,000. Now, remember we said power is work done divided by time. So we just have to divide this here now, 240k divided by 50. So once we divide that, we get our answer, which is 4,800 watts. So our answer is this. The initial velocity of an object projected from ground level is 6i plus 8g. So let's try to kind of put this in the form of a graph. So let's use this as I and we use this as g. So I is 6. So let's think of it as this being 6 and j being 8. We go 6 across, 8 up, we'll end up here. Okay, so think of it as somewhat of a triangle. So we have this here, but remember we had to go across 6, then we had to go up 8 to get to this particular point. Now if this is 6 and this is 8, it's like we have to use Pythagoras theorem to find the resultant or the magnitude of the force. Okay, so we know Pythagoras theorem is c squared is equal to a squared plus b squared. So we know that c represents a hypothesis, so this is what we're trying to find. So a squared, I could say 8 squared plus 6 squared. Then we have c squared is equal to 8 squared is 8 times 8, that gives us 64, plus 6 times 6, that gives us 36. So 64 plus 36 is 100. Now our answer would be the square root of 100, which is 10. This is equal to 10, therefore our magnitude is 10. So for this particular question, we have a vehicle with mass 1000 kilograms. Imagine it's going here, this is 1000 kg. So if this is 1000 kg and it's influenced by gravity, we multiply that by 10, which would give us the force. So the force here would be 10,000 newtons. So we already have that already, and it's at an angle of alpha to the horizontal, which we have here. This is the horizontal at a constant speed. So this constant speed is important. This implies that the sum of the forces are equal to 0. Okay, that means it's an equilibrium. So we know that work done is equal to force times distance. So what we need to figure out is a force, and then we could do that. Now this question didn't say that we have any friction occurring. They only the force as a result of gravity that was considered, as well as whatever force is pulling it against that. So remember, we always have to split this into x and y components. So inside here is alpha. It will be the same as this one here. I explained this concept thoroughly in another video, so you could check that out. So what we are trying to find is this force going parallel to the direction that this car is going up. So if you look at it, there's one going here. Let me just put it in blue. This force going this way against this force too. So you see how these two forces moving along this here, this same direction, they're parallel. And remember what we just said, the sum of the forces in that direction, we call it the x direction, is equal to 0. So the net force is equal to 0 since they're in equilibrium. Okay, we know that because they're going at constant speed. So walking out this part here, we have opposite, because this is the alpha angle opposite over hypotenuse. This is the hypotenuse here. So we could say sine alpha is equal to opposite, which we are trying to figure out, over hypotenuse, which is 10,000. So now we could try to make O the subject. So if we cross multiply, we'll end up with 10,000 times sine alpha is equal to the opposite. So we already know what sine alpha is equal to if you look at it here, which is 1 over 100. So we could say 10,000 times 1 over 100 is equal to O. So if we simplify this, we'll end up with O being 100 newtons. So this here represents 100 newtons. This blue piece represents 100 newtons. And let's just call this force here P. But you see now, they only ask us to figure out the work done against the gravity in the direction of that force. So the work done against gravity, since we have the force due to gravity, this is the force due to gravity. So if we wanted to figure out what this value is, we could use this formula. But all we want is the work done. So we have a force, so there's going to be force multiplied by the distance traveled. Now we don't know what the distance traveled is, but look what they said. They said we traveled for 25 meters per second for 1 minute. So how much is 1 minute? 1 minute is 60 seconds. So each second, if we're traveling for 25, that means that the distance we travel is 25 times 60. And remember, it says work done against gravity. So we are only concerned about the aspect of gravity in order to work that out. So the force of gravity is 100. So we'd say 100 times 25 times 60, which gives us 150,000 joules. So answer is 150,000 joules. The force and the distance was along this plane here. When a number of particles, each of different weights, are released vertically, the acceleration of each particle is expected to be the same, because the impact of gravity will be the same no matter what we use. An object is pulled L meters, so you kind of sketched this already. It moved L meters along a smooth horizontal surface by a force P newtons, which is at an angle of 45 degrees to the horizontal. Calculate again the work done. So you know we require the force and the distance going in the same direction. So we already have the distance, which is L. Now we need a force traveling along this direction here. Okay, so if we're trying to find this, we could break this into X and Y components. Now this part here that we're looking for would be the required force, this force right here, and that force is technically the adjacent. So if this force here is P and this here is the adjacent, we could say that this here would be equal to cosine 45, which is adjacent, so this one that we're trying to figure out here, over P. So to get adjacent by itself, we cross multiply, we would end up with P cosine 45. Because remember, if this was over 1, we cross multiply. P times this is equal to A. So P cosine 45. So what is cosine 45? That is 1 over square root 2. So we're going to have P times 1 over square root 2, which is the force going in this direction. So we know that this represents the force. Remember, we said we also have the distance. So that answer would just be P times 1 over square root 2 multiplied by L. So if we put all of these over 1, we'll have P times L, okay, over square root 2. So our answer is this right here. So for this particular question, they say we have three forces P, Q, R. So let's say this was P, this was Q, and this here was R. So what they're telling us is that the magnitude of P is 10. And it says the angle between P and R is 120. So between here would be 120 degrees. And the angle between Q and R is 150. So that makes it easy for us, right? Because all three of these supposed to add up to 360. So 120 plus 150 is 270. If we take that away from 360, we would be left with 90. So we know that the angle in here is 90 degrees. All right, so we need to put this in Lamè's theorem. Now remember, Lamè's theorem is going to be P over 150. They tell us P is 10, but since they're using it in terms of P, we have to say P over 150. So let's see which one does not have P over 150. So we could cross this out. We could cross this out as well. So we have P over 150, which this has, as well as this. And then we could say R over sine 90. This has R over sine 90. This one does not. So this one is out. So this is our final answer, because then we have Q now over sine 120. So the answer for this one is this. Alright, so taking this from the same question that we had earlier, we need to figure out what is the magnitude of Q. So based on Lami's theorem, what we can say is we have Q, which goes over sine 120, and that is equal to 10, which would be where P was 10 over sine 150. In order to figure out what Q is, we need to make Q the subject. So now what I'll do is cross multiply. Therefore, I'll say Q times sine 150 is equal to 10 times sine 120. So therefore, we'll have Q times sine 150 is equal to 10 times sine 120. Now, if I want to get Q by itself, I divide both sides by sine 150. So now I could put this in the calculator and that will give me the value of Q. So if you type this into the calculator, 10 times sine 120 divided by 150, you would end up with 10 square root 3. Therefore, answer is 10 square root 3. Question 40. So we have a car of mass 1000 kilograms. So let's say this is our car and it has a mass of 1000 kilograms. Okay, so that's 1000 kilograms. It's traveling from 15 meters per second to 20 meters per second for 10 seconds, and it goes against a resistance of 270. Now we need to figure out what force is acting on this as a result of this move here. So from 15 meters per second to 20 meters per second in 10 seconds, you need to figure out what that acceleration was. The fact that it says it has a constant force, that means that constant force is due to constant acceleration. So what is the force that is being pulled here as a result of our actual acceleration we have here? So we have to work that out. Since it's constant acceleration, we can use the Suvat formulas. So we have V, this here is the final velocity, and this here is the initial velocity, which is U. So V is equal to U plus, we want to figure out what acceleration is, and we have a time. So V is equal to 20, which is equal to U, which is 15, plus acceleration multiplied by time 10. So then we'll end up with 20 take away 15, which is equal to 10a. 20 take away 15 is 5, which is equal to 10a. So if we divide both sides by 10, we will get that acceleration is equal to 0.5 meters per second squared. Now, what we're saying is that there's a force due to this acceleration, which is the net force. So this net force is equal to mass times acceleration. We'll look for the sum of the forces in the x direction. So what's happening here with the mass times acceleration, it's actually going to be 1000 kilograms times 0.5. Now remember, we have a attractive force that has to maintain this force here, which is the net force, as well as the friction. So when we multiply this, we end up with a net force of 500 newtons. So what we're saying with these sum of the forces is the sum of the forces of Fx. Let's say we had a force here P. So we're saying this P here is whatever is pulling this, and then we taking away 270. But remember what we just said, the net force, or MA, is equal to 500. So we could say 500 is equal to whatever this force here in general is minus 270 gives us this 500. So to get a P, we just add 270 to both sides. We have 500 plus 270, which is equal to P. Therefore, whatever force is pulling this entire system has to be 770 newtons, because in essence, this whole system needs to pull the 500 newtons as a result of the acceleration, as well as the force that is going against it due to a resistance. That is why in this case, whatever is pulling this entire system has to be 500 plus 270. So the answer in this case is 270. Now this question says a cricket ball leaves a batsman bat at a horizontal angle of 30 degrees. Say we have a ball here, and this ball goes and it has an angle of 30 degrees. But what we're saying is that this ball covers a horizontal distance of 100 meters. So let's say the ball ended up falling here, which is 100 meters away. So there's actually a formula for horizontal range. So the horizontal range is equal to v squared times sine 2 theta over gravity. We have the angle, which is 30. We have gravity, which is 10. We have the horizontal range, which is 100. All we need to find is v. So if I substitute all of these things, I would end up with 100 is equal to v squared sine 2 times 30 over 10. So now to get the v squared by itself, I could put 100 over 1 to cross multiply. So therefore I will get 100 times 10 is equal to v squared. Now 2 times 30 is 60, so I could say just sine 60. And then now at this point I would have 1000 is equal to v squared sine 60. So if I divide both sides by sine 60, I would end up with whatever v squared is. So in this case, if I work this out, I get 1154.7. So then now to find v, I just need to find the square root of this. So the square root of this is 33.98. Now the question said that we need to put the answer to the nearest whole number. So the nearest whole number for this would be 34 meters per second. So this is our answer right here. All right, so we have these questions here now, and it says we need to figure out the total distance traveled. So if you look at this side, it has velocity on this side, and we have time on this side. Now the thing about this is that once we find the area underneath a graph, we could figure out what the total distance is. So this has to be a velocity time graph. Okay, so it maintained the speed for 9 minutes. So from here to here is 9 minutes, and here to here is 14 minutes. So if you look at this, I have what we call a trapezium. Now notice this time is in minutes and this says kilometers per hour. So I need to convert 9 minutes and 14 minutes into hours. So how many minutes do we have in an hour? We have 60 minutes. So in order to convert this to an hour, all I need to do is write it as 90 over 60. So 90 over 60 hours, right? Because it's not a full hour, it's just a proportion of hours. So we do 9 minutes out of 60 minutes. We will consider that a proportion of the hour. Likewise, same thing here. We would say 14 out of 60, which represents a portion of that particular hour. So if I was to draw this separately as a trapezium, we could actually use these figures and work out what the area is. So these are the parallel line. Above here would be 9 over 60, and here would be 14 over 60, and the height is 60. Now remember, area of a trapezium is half a plus b times height. And this height has to be the perpendicular height. A plus B represents the parallel lines, which would be these two lines here. So then we could say half 9 over 60 plus 14 over 60. And then we would say multiplied by the height, which is 60. So if I simplify this, I would have half, since they have the same denominator, 9 plus 14 is 23 over 60 multiplied by 60. So I could just put 6 over 1. These could cancel, and I would be left with 23 over 2. If you want, you could put this in your calculator one time. You will get the answer. So 23 divided by 2 would give us 11.5. So remember, we already converted this to hours. And since this is kilometers per hour, our unit would be 11.5 kilometers. And if you look here, we have that answer here. So our answer is 11.5. And remember, they said the total distance, that's why we calculated area under the entire graph. All right, so for the next question, they require us to calculate the acceleration of the bus. Now, if you have a velocity time graph, in order to calculate the acceleration, you just need to figure out what the gradient is. So in this case here, we have an acceleration right here. This is when it was increasing its speed, okay? And if you look at this, it says the bus starts from rest, which would have been here, from terminal R, and accelerates uniformly for 3 minutes. So you see, it accelerates uniformly. So we are trying to figure out what is the acceleration here. Okay, now remember what we said here. We're gonna use it as 3 over 60 to represent hours, because we're working with kilometers per hours, and we need to convert these minutes into hours, which would be 3 out of 60. So if I'm gonna read this as coordinates, I need to figure out what the coordinates are to get the gradient. Remember, we need 2 points to get a gradient, so we could work it out in the form y2 take away y1 over x2 take away x1. Now this particular component here, we have 0, 0, and this one here would be 3 over 60, and then it would be to 60. So now I need to find the gradient of this, but I'll call this x1 y1 and call this one x2 y2. Let's see if we could convert this, since they want it in meters per second squared. Let's see if we could convert this one time into meters per second squared. Remember, we said that here is 3 minutes, so if I convert 3 minutes to seconds, it would be literally times 60. So then it would be 180 seconds. So I can replace this part here with 180 seconds if we choose. So technically this would be 180. And then now we have 60 kilometers per hour. So let's do a little walking on the side here. So 60 kilometers per hour. We want to work out first what is this 60 kilometers in meters. 60 kilometers is the same as saying 60,000 meters per hour. Now if I want to turn this to seconds, I need to figure out how many seconds are in an hour. The number of seconds in an hour would be, we have 1 hour has 60 minutes and each minute has 60 seconds. So this is 3600. So I'll end up dividing 60,000 by 3,600 to get meters per second, which would basically give me 50 over 3. 50 over 3. So I can put over here 50 over 3. Okay, so now I could work this out. So we know that this here is in meters per second, and we know that this over here is in seconds. So if I was to do this y2 take away y1, I'll end up with 50 over 3 minus 0 over 180 take away 0. This would simplify to basically 50 over 3 divided by 180. And once you put this in the calculator, you'll end up with 5 over 54. If you don't have a calculator that allows you to do that, you could do it a traditional way. So you have 50 over 3. Then since we're dividing by 180, that would change to multiply by 1 over 180. 10 into 50 goes 5 times. 10 into 180 goes 18 times. So then you will have 5 times 1 is 5 over 3 times 18, which is 54. So our answer here is 5 over 54. Alright, so for this particular question, it says that we have two vehicles. We have like a truck. Let's just use a box to represent a truck. It has a mass of 3,000 and it's moving at 2.4 meters per second. And there's a mass that is 1,500 and that's moving at a speed of 1.2, but they're going in opposite directions. Okay, so we have one truck going this way and we have the other mass moving this way. So this is before collision. Now we want to see what happens after collision. So after collision, when they hit, they move together. So because they move together, we can say that they are going through the same velocity. All right. So the conservation of momentum says that momentum before collision is equal to momentum after. So the momentum before we would have for the first one, remember momentum is equal to mass times velocity. The mass times velocity for this particular one would be 3,000 times 2.4. So let's call that M1 times initial, which is U1. And we're going to add that to the second one. But remember, now that it's going in a different direction, the sign also will be different. So in this case, yes, we would say 1500 is a mass, but because the velocity is going in the opposite direction, like you see here, we can say that moving this way is positive, going this way is negative. We would say that 1500 is multiplied to negative 1.2. So that's M2 for the second mass multiplied by its initial velocity. And the momentum after, we're saying that the same M1 multiplied by V, which is going to be 3000 V plus M2 times the same V. Remember, because they collide, they have the same V. So that's going to give us 1500 V. So let's simplify this now and see what we get. So here we would end up with 7,200, and then here this would end up being minus 1,800 because we'll end up with a negative here, right? So it's almost like saying the same thing as this, subtract that, which would be equal to the sum of this. So 7,200 plus negative 1,800. So we'll be left here with 5,400 is equal to 4,500 V. To figure out V, we have to divide both sides 4500, which would give us 1.2 meters per second. So the velocity after collision that these two forces, after they hit, these two masses after they hit, would be going at is 1.2 meters per second. So for this particular question now, they want the total kinetic energy after impact, after these two hit. So after they hit, notice what we had. We had a combination of the 3000 and the 1500, but we will still do it separately, but we could have combined it and worked it out, right? So kinetic energy after would be equal to half the mass of the first one multiplied by the velocity of the first one squared plus half mass of the second one times the velocity of the second one, which is the same as the first one squared. In this case, it was the same. Just showing you this way in case you do any other question. So KE is equal to half times 3000 times v squared. So what is v squared? What was the final velocity? 1.2. So 1.2 from our previous question squared plus half times the 1500 again multiplied by 1.2 squared. So this will give you 2160 plus 1080. So that would give you 3240 joules. So that's our answer, 3240 joules.